Hi, friends. I'm Radu, and in the next 10 minutes, we're going to talk about WebAssembly, Rust, and the component model. So I'm Radu. I work at Fermyon. I'm really passionate about WebAssembly and distributed systems and computers in general. When I'm not around computers, I enjoy classical music and cycling and bubble tea. And yeah, a couple of months ago, we launched Spin, which is our first major open source project. You can find it at spin.fermyon.dev and, of course, on GitHub. And Spin is an open source framework for building and running microservices with WebAssembly. With Spin, our main goal is making sure that you can write WebAssembly on the server side and take advantage of the portability and security and speed of WebAssembly. Spin is entirely written in Rust and lets you write microservices in Rust as well, but also in any language that compiles to WASI, which is the WebAssembly system interface. And before I get any further in talking about WebAssembly and Spin and how everything fits together, the main thing I wanted you to take away from my talk is in Rust, if you want to write a Spin microservice that compiles to WebAssembly, all you have to do is write this function. It's just a regular Rust function that takes in an HTTP request, returns an HTTP response, and that's about it. You annotate it with a proc macro, and that's about it. Anything that compiles to WebAssembly can be used in this function. You can import any crate from crates.io that compiles to WASI, and in Spin, microservices are just functions. So taking a step back, I think I've said the word WebAssembly 20-ish times so far. So taking a step back, WebAssembly is just a binary format for a virtual machine. In familiar terms, it's literally just a compilation target initially built for the web with the goal of bringing languages like C and C++ and Rust and other languages to the web. And for a browser and for a web environment, the main reasoning behind WebAssembly was, well, we want a cross-platform and cross-architecture format. We want something with a really compact binary size and conversely fast startup times. And we want something that runs in an isolation sandbox. Specifically, you don't want application in tab 3 to have access to anything in tab 1, which might be your banking account, nor do you want a random person that writes JavaScript that runs in your browser to access anything on your machine. So isolation in browsers is super, super important. So at Fermyon, we come from working on cloud computing for the last decade or so. And essentially, we looked at the cloud computing landscape and we saw the progression from VMs to containers and to the far end of the spectrum, serverless and function as a service. And identified a gap right in the middle, which is, well, containers are not cross-platform, they're not cross-architecture, they are large and backing entire Linux file systems. They have really slow startup times. And then on the other hand, serverless and FAS have really nice application models. They have really good developer experiences, but usually they lock you in a specific vendor and no real observability into what the system is doing. And essentially, we try to figure out whether we could build something that fits that gap in the middle. And WebAssembly, it turns out it's really good for the browsers, but it's great for cloud computing. As we talked about, that WebAssembly is cross-platform and true cross-architecture. You compile once and you can run that in an ARM processor or an AMD CPU or any other processor. It's also multiple language, so it's cross-programming language. It yields really small binary sizes. It runs everything in a secure sandbox, and we'll look at it in a second. But it's really scalable, either from 0 to n and then back again. And you will probably see this slide pretty much whenever people talk about server-side WebAssembly, but I think it's important to emphasize it once again. The person who initially built Docker, Solomon, was talking about, well, if WebAssembly and the system interface, WASI, existed when they started Docker, they might have not started Docker at all, just because WebAssembly has the potential to be really powerful on the server side. So let's have a look at how you would build and run your first application with Spin. The only thing I did on my machine was configure the Spin CLI. So I can use the Spin new command to start a new microservice in Rust. Just a hello world. and it created the application for me. And now I can do a spin build, which we'll just call cargo build behind the scenes. And then I can do spin up. What this does is it takes the WebAssembly binary that I just built and it starts it locally in a server. Now, let's look at what actually got generated for me. And if you remember the first or so slides, it's literally just that function. It's hello world function, takes in a regular HTTP request and returns a result of a response, and it just writes hello world. Let's change that slightly and then run spin build again. And there's a convenience flag that just restarts the app after it's built. And now it's hello Rust Australia. And of course, behind the scenes, Spin is built on the Bytecode Alliance tooling like WebAssembly Component Model and Wasmtime, and entirely written in Rust. Both of projects are as well. And you build your component into a WebAssembly module, and then you publish it to a registry. For each new request, Spin takes your WebAssembly module, and it will create a new isolated WebAssembly instance to handle your request and then shut it down. Essentially running it in a true isolation sandbox, each request from any other request of the same component or any other application that happens to run on that host. Spin is not just HTTP. It has built-in support for HTTP trigger because we think HTTP is one of the most popular workloads, but it also has a built-in support for PubSub with Redis, where a component gets instantiated and invoked for every new message on a Redis channel, and we're working at and looking at adding support for other PubSub mechanisms. But the important thing is you can extend the Spin application model to build your own triggers. It's open source and it's built on the open WebAssembly standard, the component model. So you can build it, and hopefully in the future it will be compatible with other WebAssembly component model tooling. And we are both working on new application models and triggers, and we know people who are interested in building support for WebSockets and MQTT and cron jobs and more. And it's not just Rust. While Spin is written in Rust, and as you might know, Rust has really good support for WebAssembly. Spin lets you run components that are written in any language that compiles to the WebAssembly system interface. And we also have dedicated SDK support for Rust, Go, and working on adding a bunch more. Think JavaScript or C# or Swift or other popular languages that compile to WebAssembly. And while Spin is the developer tool, we also recently open sourced the platform for running your Spin applications. So we saw Spin build, Spin up to talk about your inner developer workflow. And then to push that to somewhere where you can run it in production, we have Spin deploy, which just takes your application, packages up, and sends it to some infrastructure that happens to run in the cloud. And as we were looking at the waves of cloud computing, at no point did a new step just obliterate entirely the previous ecosystem. So VMs didn't replace containers, and as we'll most likely see over the next couple of years, WebAssembly will not entirely replace containers. So we really believe that WebAssembly is going to be huge for distributed computing, but containers will most likely be around for a long, long time. So the open source Fermyon platform that you can find on fermyon.dev is built on the HashiCorp Nomad stack. So you can run WebAssembly microservices and containers side by side and compose applications and gradually migrate from container-based microservices to lightweight and really, really fast WebAssembly microservices. And if you're interested in an example of exactly how to do that, we have a cute cat game called Finicky Whiskers that you can find on finickyWhiskers.com that is essentially built with six WebAssembly microservices, Redis running in a container, all running in HashiCorp's Nomad stack. So behind the game, if you look there, essentially the same thing happens where every time you click a button, we instantiate the WebAssembly module to handle your request and then shut it down. There are definitely more efficient ways to do things, but Finicky Whiskers is a manual load generator. Finally, I just want to say a big thank you to the WebAssembly community. None of the work in server-side WebAssembly or anywhere else would be possible without the amazing people working on standardizing and implementing WebAssembly. And I'll just want to single out the Bytecode Alliance people working on things like Wasm-Time and the component model and adding support in Rust and in other languages. So really thank you to the entire WebAssembly community. Thank you.